Hello everyone, this is Gauri from Mathematics Department, SNS College of Technology. Today we are going to discuss about vector calculus. So last class we discussed about multiple integrals and some of its applications. Today we are going to discuss about vector calculus. First let's see the definition of scalar and vector quantity. So what is mean by scalar quantity? It is nothing but which has magnitude and it's not related to any direction. That is called scalar quantity. So in the case of vector quantity, so which has both magnitude and direction. So next definition is scalar point function. So if corresponding to each point P of a region capital R, that corresponds to a scalar denoted by phi of x comma y comma z, then phi is said to be scalar point function for the region capital R. Let's see the example. The temperature phi of P at any point P of the body occupying a certain region is called scalar point function. So in the case of vector point function, so there corresponds a vector denoted by f of P, then f is said to be vector point function for the region capital R. Here the example is the acceleration f of P of a particle at any time t occupying the position P in a certain region is called vector point function. Next, we are going to discuss about the differential operator. So, it is denoted by del. The vector differential operator is defined by I vector into, here we have three dimensions. Therefore, the formula is given by I vector into dou by dou x plus j vector into dou by dou y plus k vector into dou by dou z. Simply, we can written as summation I vector into dou by dou x. Next definition is gradient. So, gradient of a scalar point function. Here the notation is del phi. So let us consider phi of x comma y comma z be a scalar point function and is continuously differentiable. Then the vector is given by I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Note that here it is also denoted by grade phi. So it is a vector field function. So del phi is not equal to phi delta. So there will be no dot and cross product between phi and delta. Here next we are going to discuss about some properties of gradient. First let's see the linear property. So if f and g are two scalar point functions, then del of f plus or minus g is equal to del f plus or minus del g. Next property 2, if f and g are two scalar point functions, then del of fg is equal to f into del g plus g into del f. If f and g are two scalar point functions, then del of f by g is equal to g into del f minus f into del g by g square. Here g is not equal to 0. Next, fourth property, gradient of constant is 0. Del phi is equal to 0. Next, we discuss the problems. So, find grade phi. Here, phi is given by x square plus y square plus z square. First, write the formula for del phi. Del phi is equal to I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Here, phi is replaced by x square plus y square plus z square. Then first we have to differentiate the phi with respect to x. So differentiation of x square is 2x. Therefore I vector into 2x. Next with respect to y. So differentiation of y square is 2y. Next last one, differentiation of z square is 2z. Therefore my answer is 2x into I vector plus 2y into j vector plus 2z into k vector. Similarly, second problem, so find grade phi if phi is equal to xyz at a point 1 comma 1 comma 1. So finally you replaced xyz by 1 comma 1 comma 1. First write the formula for del phi, that is equal to I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Here phi is replaced by xyz. First we have to differentiate with respect to x. So differentiation of xyz is answer is differentiation of x is 1. So yz is treat as constant. Therefore I vector into yz. Similarly j vector into xz plus k vector into xy. Next step is you have to replace xyz by 1 comma 1 comma 1. So finally I got the answer I vector plus j vector plus k vector. Next one is find grade phi. Here phi is given by 3x square y minus y cube z square at a point 1 comma 1 comma 1. So del phi is equal to I vector into dou phi by dou x plus j vector into dou phi by dou y plus k vector into dou phi by dou z. Here you, instead of replace phi by 3x square y minus y cube z square. First differentiation of x is 6xy. Next with respect to y I will get 3x square minus 3y square z square. Then last one you have to differentiate with respect to z. You will get minus 2y cube z. So next step is you have to replace all x, y, z by 1, 1, 1. So the answer is del phi answer is 6i minus 2k. Look at the fourth problem. Take this as homework. Here the point is not given. Find del phi. Phi is equal to log of x square plus y square plus z square. So tomorrow all of you come with the answers. Thank you, students.